Hi, today I'm going to discuss 3 AI-related techniques used in this group project. The first technique is greedy-based first search, which searches for the best action based on a heuristic function. Here is our code. Actions that change color along the edges of the bird are highly rated by the heuristic function, and our goal is to turn the opponent's color into ours as much as possible. For greedy-based first search, the main challenge comes from how to define the heuristic function. We find that the edges of the bird have extreme significance. If we can take up the cells along the edges before our opponent, we have a higher chance of winning. This search is a combination of BFS and DFS, which has the advantages of both and is more efficient. But this is not optimal and it may get stuck in a DFS loop. To improve, we can combine it with other AI techniques to design better heuristic functions. The next is the multi-color tree search. We use a dictionary to record the score changes of actions and guide the next search, combined with the grid-based search tree. The selection is the sum of the score in MCTS and the value of the heuristic function. If the action does not been explored before, we only select the state with the largest heuristic value. How to combine MCTS and grid-based search trees is a challenge. We modify the scoring function to take activities of the exploitation function in MCTS. MCTS supports the asymmetric expansion of search trees. It can be saved in an intermediate state for future retrieval. However, how to balance exploration and exploitation is a problem. As the search tree grows, it requires a lot of memories and takes a long time to run due to a large number of iterations. ANN can be used to improve it. Finally, we use the minimax algorithm to simulate the behavior of the opponent agent, by assuming that both agents always choose the best action from their perspectives. In this project, we assume that each agent takes the action that leads to the maximum value of the heuristic function. How to combine the mini-maximum algorithm with others is still a big challenge. We find that the state transaction algorithm. We apply mini-maximum algorithm to model the state transaction. When the opponent acts wisely, it chooses the best action, which means it is optimal. If the opponent plays the game in the best way, it is complete and able to find the solutions in the finite tree, and its space complexity is relatively small. But sometimes the opponent does not act according to our assumption, and our algorithm cannot predict that. It slows down when we play the large game. In the future, we can use alpha-beta pruning to improve the training time of the algorithm. Thanks for listening. That's all.